Hi students, good morning everyone. I think all of you are very much fine and good. Welcome to JEE Maths Mantra. So in this session I am going to take your chapter, that is permutations and combinations. Okay. So quickly all of you join the class so that we can start the class. Okay. So tell all your friends to join as much as early possible so that we can start the class. Hi everyone. Good morning to all. I think from 1 week I have not taken class for 11th class students, but no problem because I was in fully engaged with 12th class students. No problem, because we have to give some importance for 12th class students more than 11th class. No problem. And I am today here with your one of the chapter, that is permutations and combinations. Okay, so I am going to deal with the synopsis and multiple choice questions of this permutation and combination for your JEE mains and CET purpose. Okay, so I feel that all of you are very much happy as well as fine. We can start our class about permutations and combinations. Okay, so quickly see, before you start your permutation and combination, you must know the fundamental principles of counting. So in the fundamental principles of counting, you have two ways of fundamental principle of counting. One is fundamental principle of multiplication and another one is fundamental principle of addition. Okay, so here in the fundamental principle of multiplication, let us see what is the meaning of fundamental principle of multiplication, because before we go for our permutation and combination, you must know what is multiplication method and what is addition method in the fundamental principle of counting. Okay, so whenever there is one event or whenever there is one experiment, we have to calculate the number of ways or the number of elements or the number of objects in that. So for that we need fundamental principle of counting. So for that purpose, first let us go with fundamental principle of multiplication. You just say fundamental principle of multiplication. You take this example, that is, there are three shirts and one belt and two pants. Okay, so now I want to calculate in how many ways we can complete this work. Okay, or we can complete this dressing. Or the boy has to be dressed. Okay, you have three shirts, one belt and two pants. So using three shirts, one belt, two pants, in how many number of ways the boy has to be dressed? That is the main important thing. Okay, so you can just see here, they have given 9 ways. Clear? So here you have 3 ways. Okay, and in the second row you have 3 ways, and in the third row you have 3 ways. So total number of 9 ways you have. So that means a boy can be dressed in 9 number of ways. The boy can be dressed in 9 number of ways. Okay, So how to calculate this? That is very, very important. How to calculate this? The number of ways the boy has to be dressed or the boy is going to be dressed is very, very important. So in this type of cases, we have to go through the fundamental principle of counting and we have to calculate it. Clear? So first you understand what is the fundamental principle of multiplication. You just see, if an operation can be performed, in m different ways, following which a second operation can be performed in n different ways, then the two operations in a succession can be performed in m into n ways. Okay, that means an operation can be performed in m different ways, following which a second operation can be performed in n different ways. That means here you just see, he has to be dressed with shirt, he has to be dressed with belt, and he has to be dressed with pant. You have three ways. That means you have three type of different ways. Okay, so one is you have 3 shirts, 1 belt and 2 pants. Are you getting my point? So that gives you how many ways? You can just see 3 plus 3 plus 3, 9 different ways it gives you. Okay, so that's why here you have to be very, very careful. It is given by m into n different ways, Okay, so you can just see this as 3 different shirts and this has 3 different objects. In that you have 2 pants and 1 belt. Okay, so 2 plus 1, you have 3 different objects here. Totally, you can just see here, you can calculate it in the form of 3 into 3. In this 3, you have 1 belt plus 2 pants. Clear? So total you have 9 ways. Where a boy can be dressed. Okay. So in this way you have to calculate the fundamental principle of multiplication. That means m different ways means here m different shirts, he has 3 different shirts, and he has 2 plus 1 different of pants and belt. Okay, so now he got total 9 different ways where he can be dressed. Are you getting my point? So first you have to be very careful with the operations that has to be taken here. Okay, so if one complete experiment has to be done, then here what happens? First you understand one thing. If one experiment or work, okay, so one experiment or one work to complete, see here, m different ways follows n different ways. Okay, m different ways follows n different ways. For example, in this 3 shirts follows 2 plus 1, that is 2 shirts and 1 belt. Okay, sorry, 2 pants and 1 belt. Are you getting my point? 2 pants and 1 belt. Clear? So then only the work will be done. Or the experiment will be over. Okay, so unless and until he dress up with all 3, that is shirt, pant and belt, he is not going to finish his work. Okay, so that's why if he has to be get dressed up, here m ways will follows n ways. That means the wearing of 3 shirts will follow the wearing of 2 pants plus 1 belt. So are you getting my point? So in that ways you can just say 3 into 3, that is 9 ways he have. 3 into 3 he have 9 ways, because by only getting a shirt he will be not completing his work. If he wear only pant, he will not complete with his work. his work will complete only when he wears pant, he wears a shirt and he wears belt. Okay, so then only the experiment is going to be over. So that's why please remember here, if this work has to be done, he has to go with shirts, he has to go with pant and he has to go with belt. Then only the complete work is going to be done. Okay, so here you just remember, if m ways of the first work continues with the n ways of the second work, is going to be calculated with m into n ways, is going to be calculated with m into n ways. So that we call it as the fundamental principle of multiplication, that we call it as fundamental principle of multiplication. Okay, so this is called your fundamental principle of multiplication. So everyone quickly give me thumbs if you are understanding the class. Quickly give me thumbs if you are understanding the class, so that I can also understand that you are following the class and you are understanding the concepts. So quickly tell me, all of you, have you understood this fundamental principle of multiplication? Quickly tell me, have you understood this fundamental principle of multiplication? Okay. So now we can go for fundamental principle of addition. Now we can go for fundamental principle of addition. See here, I have 3 tabs. I have 3 tabs. Okay, and 5 mobile phones. I have 5 mobile phones. Okay, 5 mobile phones. Clear? So now you see my work is, I have to give one mobile or one tab. One mobile or one tab. This is my work. I have to give one mobile or one tab. For take some person name A. For person A, I has to give one mobile or one tab. So in how many ways I can give? See here, you have 3 different tabs and 5 different mobiles. 3 different tabs and 5 different mobiles. Okay, all 3 tabs are different, all 5 mobiles are different. Now I want to give one mobile or one tab for one person A. In how many ways I can give? Can you tell me? So see here, 3 tabs means 3 ways, 5 mobiles means 5 ways, 3 into 5 ways, that is total 8 ways I have. Total 8 ways I have. I can give tab 1, I can give tab 2, I can give tab 3. I can give mobile 1, I can give mobile 2, I can give mobile 3, so on, mobile 4 and mobile 5. Are you getting my point? So therefore here I have 5 different mobiles and 3 different tabs. Okay, so see here, not 15. Please remember, this is not 5 into 3. This is not 5 into 3. This is 5 plus 3. Please see here, I am not giving mobile and tab. I am not giving both. I am giving only one. Either I give mobile or I give tab. Are you getting my point? See, if I give tab T1 for person A, my work is over. Are you getting my point? If I give mobile 1 to person A, my work is over. Are you getting my point? That means I may give one tab or I may give one mobile. Are you getting my point? So that's why here it is just different from the first fundamental principle of multiplication. It is just different from fundamental principle of multiplication. In multiplication, what happens? M ways continue with n ways. M ways continue with n ways. That means the wearing of shirt continues with the wearing of belt and pant. The wearing of shirt will continue with the wearing of belt and pant. But here you just see, giving tab will not continue with giving mobile. Are you getting my point? with giving mobile. Here you have to be very practical. Are you getting my point? Because if I give one tab T1 to person A, my work is over. So like that, how many works I can do? I have 8 different things. That is 3 tabs I have, 5 mobiles I have. Okay. So 5 plus 3, 8 objects I have. 8 objects I have. Okay. So in this 8, if I give one, my work is over. Are you getting my point? So that's why, see here, you have 8 ways to complete this. You have 8 ways to complete your work. To complete your work. So in this type of situation, we use in this type of situation we use our fundamental principle of addition. Our fundamental principle of addition. Okay. So now from this you can just see. From this you can just see. We can. So from this you can just see that to complete this work you got 8 different ways. To complete this you got 8 different ways. So you may get confused here with 3 into 2 into 1. But my dear students, you listen here. You just see here. Without no belt also he can dress. Without no belt also he can dress. Please see this. Without no belt also he can dress. There is no rule that he has to wear belt. There is no rule that he has to wear belt. Think practically. Okay, are you getting my point? Think practically. These 3 are the additional choices. 1, 2 and these 3 are the additional choices. You have 3 shirts. You have 3 shirts. You have 2 pants. No problem. 3 into 2 ways you can get over. But no problem. Without belt also he can dress up. No problem. With belt also he can dress up. No problem. But if he don't wear a pant, there is a big problem. If he don't wear a shirt, there is a big problem. This will be incomplete. This will be incomplete with shirt or pant. But no problem. Without belt also he can finish his dressing. Without belt also he can finish his dressing. Are you getting my point? Think practically. Okay. So here you got 9 ways. Clear? On the same way you can come here. You got 8 ways of giving mobile and tab. Okay. So that you can just see. If an operation, you go through the definition now. If an operation can be performed in m different ways and other operation can be independent of the first operation, can be performed in n different ways. So that is what we say. Giving tab will not continue with giving mobile. That is what your independency. That is what your independency of the first operation. Of the first operation. Are you getting my point? Clear? So now independent operations here means giving tab and giving mobile are 2 different independent operations. Are you getting my point? There is no rule that if you give tab you have to give mobile. There is no rule that if you give mobile you have to give tab. Okay. So by that you can just say giving tab and giving mobile are 2 independent events. Okay. So if these 2 independents are event present, you have 8 ways. Clear? So from that we can say we can complete this work with 8 different ways. Clear? Okay. I think all of you have understood this. So quickly tell me fundamental principle of addition and fundamental principle of multiplication. Have you understood this? Okay. Now you can just see. if I give the same problem, the number of ways of giving one mobile and one tab for person A, question mark. So now tell me the answer. The number of ways of giving one mobile and one tab for person A, where he have 3 different tabs and 5 different mobiles. Okay. Now tell me the answer. What are the number of ways here? Okay. Please quickly tell me what are the number of ways if he have 5 different mobiles and 3 different tabs. 5 different mobiles and 3 different tabs. Very good. Some of you are giving the right answer. Now you have 5 into 3, 15 ways. Now you have 5 into 3, 15 ways. Why? Because you just see here, giving mobile continues with giving tab. That means here my work will complete only when I give one tab and one mobile. My work will complete only when I give one mobile and one tab. Are you getting my point? So here you have 15 ways, but in the second ways you just think the number of ways of giving one mobile or one tab to person A. What is the answer? You just think through this. You will have a clear idea of fundamental principle of multiplication and fundamental principle of addition. So you just think about these 2 questions. You will get a clear idea of fundamental principle of multiplication as well as fundamental principle of addition. Okay. Now you give me answer to the second question. So the number of ways of giving one mobile or one tab. See here, my work will complete if I give one mobile, either if I give one mobile or one tab. So that means here you have 8 ways. Are you getting my point? So that means first you have to think it is independent or dependent. See, here it is independent. Okay, here it is dependent. That means giving mobile depends on giving tab and giving tab depends on giving mobile. Both the events are dependent events, but here giving mobile and giving tab are independent events. Okay, so you have to think according to the problem. And you have to choose the fundamental principle of addition and the fundamental principle of multiplication. So quickly give me thumbs if you have understood this, so we can go for the next concept or one problem. Okay, so we can go to the next problem. Quickly give me thumbs if you have understood this. Clear? So all of you quickly give me thumbs if you have understood this. Yes, if it is independent, we should use addition. If it is dependent, we should use multiplication. If it is union of two sets, we take addition. If it is intersection of two sets, If it is intersection of two sets, we take multiplication. If it is independent, we use addition. If it is dependent, we use multiplication. If it is union of two sets, we take addition. If it is intersection of two sets, we take multiplication. These all things you have to remember. Intersection means addition. Sorry, intersection means multiplication. Union means addition. Okay. So now we can go for the new concept or one new problem, that is how many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated. If the digits can be repeated. Very good. You just see here 3-digit number they are asking. They are asking 3-digit number. They are asking 3-digit number where the repetition is allowed. Where the repetition is allowed. Okay. So if the repetition is allowed means you just see this box has got all 6 choice. Are you getting my point? The second box also has got all 6 choice. The third box also has got all 6 choice. Are you getting my point? So that means tell me it is comes under multiplication, it comes under multiplication or it comes under addition. Tell me it comes under multiplication or it comes under addition. I has to add 6 plus 6 plus 6 or I has to multiply 6 into 6 into 6. Please tell me. This is 3-digit number. We have to make 3-digit number. It is a fundamental principle of multiplication or it is fundamental principle of addition. Quickly tell me, it is fundamental principle of addition or it is fundamental principle of multiplication. What is my work? I has to make 3-digit number. I has to make 3-digit number. So you just see here, if I choose my first place, if I choose my first place, if I choose my first place, is my work over? By choosing the first place, is my work over? No. I has to take the second place also. By choosing the second place, my work is over? No. I has to go for third place also. So all these 3 places are dependent. All these 3 places are depending on each other. They are not complete with one another. If one of the box is thrown out of this, then this is incomplete. Then this is incomplete. Are you getting my point? It is going to be complete if and only if those all 3 boxes are together. Those all 3 boxes are together. That means they are depending on each other. That means they are depending on each other. Are you getting my point? If I throw one box outside and if I keep 2, this is called 2-digit number. It is not called 3-digit number. If I throw 2 boxes outside and if I keep 1 box, it is called 1-digit number. It is not called 3-digit number. Are you getting my point? So that's why please remember here, if you want to write 3-digit number, all 3 boxes must be there. That means they are depending on each other. That means we have to go for fundamental principle of multiplication. That means we have to go for fundamental principle of multiplication. Clear? So first box, second box and third box. See here, repetition is allowed means first box has got 6 choice. Second box also has got 6 choice. And the third box also has got 6 choice. So 6 into 6 into 6. So therefore 36, 6 cube is how much? You just check, 6 into 6 is 36, 6 into 3 is 18, 18 plus 3 is 21. So 216 is your answer. 216 is your answer. Are you getting my point? So therefore the answer is going to be None of this. Option D is the correct answer. Option D is the correct answer. Okay, so now you tell me, without repetition what happens? Without repetitions, what are the number of ways? What are the number of ways? What are the number of ways without repetition? This is my second question. This is my second question with the same thing. This is my second question. Now you said can be repeated. Now tell me without repetition what happens? Without repetition what happens? Quickly tell me. Very good. So see here, without repetition what happens? Without repetition what happens? You got how much? 1, 2, 3, 4, 5, 6. You got 6 different numbers. Okay. Without repetition means out of this 6, I will choose one and I will use it here. For this box, you got totally 6 choice. Please understand this. For this box, you have got 6 choice because in this 6 you can choose any one. In this 6 you can choose any one number and you can keep here. So that means it has got 6 ways. Okay. So now you have chosen one number from this and you have kept here. How many are remaining? Now only 5 are remaining because one is already used here. One is already used here. You are left with only 5 numbers. Okay. Now this has got how many ways? 5 ways. This has got how many ways? 5 ways. Okay. So from these 5 numbers, you choose one and you keep it here. So this box is filled. Now you got how many ways for the last box? You got only 4 ways. You got only 4 ways. That means 6 into 5 into 4. That is 120 ways. The answer is 120 ways. You got 120 number of ways to do the complete your option without repetition. With repetition it is 216. Without repetition it is 120. Okay. So my dear students, please remember one thing. Whichever exam you attempt after your completion of degree or after your completion of your PUC, there are some of the exams other than JEE mains, other than NDA, other than KCET. I am not telling about JEE mains, I am not telling about NDA, I am not telling about KCET. Other than this, there are some exams where you have to go through mathematical reasoning or multiple aptitude type of exams. We tell it as aptitude type of exams. Okay. So there you need this type of mathematical thinking. There you need mathematical thinking and this type of number of ways or number of ways of thinking in mathematics you need. Okay. So such type of exams needs this type of thinking. So please, permutation, combination, probability, these things are going to be very, very important for your those type of exams. Okay. So that's why I tell please go through it. That's why I tell please go through it. Understand permutation and combination. Understand probability very much neatly. Okay. And you can see here sets, permutation and combination and probability. These all are interrelated. These all are interrelated. Okay. Without sets, you can't understand probability. Without sets, you can't understand permutation and combination. And without sets and permutation combination, you can't understand probability. Are you getting my point? Those 3 concepts are very interrelated. So please give more importance for permutation and combination and try to understand it. Okay. So now quickly we can go for factorial notation. Quickly we can go for factorial notation. And you just see here n factorial means the multiplication of n natural numbers. The multiplication of n natural numbers. Okay. N consecutive natural numbers is called n factorial. Okay. So you can see 5 factorial means 5 into 4 into 3 into 2 into 1. So that is going to be equal to 120. 2 factorial means 2 into 1, that is 2. 1 factorial means 1. 0 factorial means 1. 3 factorial means 3 into 2 into 1, that is 6. 4 factorial means 4 into 3 into 2 into 1, that is 24. Okay. So this is all about your factorial notation. Factorial means the consecutive multiplication of n natural numbers. The consecutive multiplication of n natural numbers is called factorial. Okay. And now you see the properties of factorial. Properties of factorial means first one, 0 factorial is 1. Please remember this. 0 factorial is 1. And the second property is factorials cannot be defined for negative integers. Factorials cannot be given for negative integers. That means factorials are given only if the integer is positive. Okay. So for fractions also it is not defined. For fractions also it is not defined. Please remember this. Clear? And next, n factorial, you already know. N factorial can be written as, you just see, n factorial can be written as n minus 1 into n minus 1 factorial into n. Again the same n factorial can be written as n minus 2 factorials into n minus 1 into n. Again the n factorial can be written as n minus 3 factorial into n minus 2 into n minus 1 into n. Okay. On the same way, you can see the fourth one, n factorial divided by r factorial can be written as n into n minus 1 into n minus 2 into so on to r plus 1 factorial. Sorry, r plus 1. Okay. N into n minus 1 into n minus 2 into so on to r plus 1 factorial. Clear? So now you just listen here. If I want to calculate 5 factorial, I can write it as 5 minus 1 factorial into 5. I can write 5 factorial as 5 minus 2 factorial into 5 minus 1 into 5. Okay. I can write, see here, I can write 10 factorial as, 1 into 2 into 3 into so on to 4 into 5, 6, 7, 8, 9 and 10. The same thing also can be written as, you just see here, 10 minus 1 factorial into 10. 10 minus 1 factorial means what? 9 factorial into 10. 9 factorial means what? 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9. Okay. On the same way, I can write it as, now 10 factorial also can be written as 10 minus 2 factorial into 9 into 10. So here 10 minus 2 means what? 8 factorial. That is 8 factorial into 9 into 10. Okay. Again the 10 factorial can be also written as what? 10 minus 3 factorial into 8 into 9 into 10. Here 10 minus 3 will be how much? 7 factorial. So 7 factorial into 8 into 9 into 10. Okay. So now like this you can write. That is important property of n factorial. Okay. So for negative integers we can't write factorials. For fractionals like this, you just see, I can't write 5 by 2 factorial. I can't write this 5 by 2. I can write 5 factorial divided by 2 factorial. Okay. But I can't write 5 by 2 factorial like this. Complete 5 by 2 factorial. I can't write like this. Okay. So factorials is not defined for negative integers. factorials is not defined for fractions, but factorials can be defined for positive numbers. And you can also write 0 factorial as 1. Please remember this, very, very important. Okay. So now we can go for the next concept, that is permutation. Okay. Permutation means, you just see here, I have some n number of objects. I have some n number of objects like this. Take this as n objects. Take this as n number of objects. Okay. From this n number of objects, I will select, or I will what I will do? I will do some arrangements. I will do some arrangements like this by taking some r number of elements. By taking r number of elements. By taking r number of elements, I will do arrangements. I will do arrangements. Okay. So see here what happens. Out of n, I will choose r and I will do arrangements. If I do arrangements, it is called permutation. If I do arrangements, it is called permutation. That means from n objects, if I choose r objects and if I arrange them in some order, it is called permutation. It is called permutation. Clear? So here you can take one example, that is there are A, B, C, and I will take two alphabets or two alphabets from this. I will take two alphabets from this and I will arrange them. Then I want to calculate the total number of arrangements. So I can arrange it as AB, I can arrange it as AC, I can arrange it as BA, I can arrange it as BC, I can arrange it as CA, I can arrange it as CB. So you see 1, 2, 3, 4, 5 and 6. That means 6 arrangements, 6 ways of arrangements I can do. 6 ways of arrangements I can do by taking 3 different alphabets. By taking 3 different alphabets. Okay. So by taking 3 different alphabets, I can take this 6 different ways of arrangements. I can take this 6 different ways of arrangements is called permutation. Okay. So that is what they explain in the definition. That is each of different arrangements. See here, permutation is nothing but each of different arrangements which can be made by taking some or all number of things is called permutation. Taking some or all at a time and making an arrangements is called permutation. Okay. And we write it as NPR. Okay. Total n elements. Out of them I am taking r elements. Total I have n elements. Out of n I am taking r elements. Okay. That is your NPR. Okay. Here you have 3 objects. Out of 3 I am taking 2. That is 3P2. Clear? So this is called your permutation definition, or this is the meaning of permutation. So quickly, who all understood this? Give me thumbs. Quickly give me thumbs, all of you. I think some of you have forgotten Pawan sir, because from 1 week I have not taken class for you. So some of you I think forgotten me. No problem. If you forget me, again I will come and again I will make you remember that I am still alive. Don't worry about that. As soon as possible, I am going to take some of the concepts for you also. I am little bit busy with your JEE mains preparation for second year students as well as board preparation of second year students. So that's why I was not able to engage you people. Don't worry. As soon as I will take classes for you, and I will make you also engage with live classes. Okay, so now we can go for the meaning of NPR. The meaning of NPR. See here, NPR has its own definition, that is NPR is nothing but n factorial divided by n minus r factorial, or I can also write it as n into n minus 1 into n minus 2 into so on to n minus 2 plus 1, like this. Okay, n into n minus 1 into n minus 2 into n minus 2 plus 1. Clear? That is nothing but, you can see 3p2 is nothing but 3 into here you can just see 3 minus 1 into 3 minus 1 is 2. Okay, so 3 minus 1. Clear? So 3 minus 1 factorial, that means 3 into 2 factorial, that is 6, like that. Okay, so now you can use NPR formula. You can use NPR formula and you can write that is 3p2. 3p2 is how much? 3p2. Okay, that is 3 factorial divided by 3 minus 2 factorial. So that will be 3 factorial divided by 1 factorial. So 3 into 2 into 1. Okay, so see here you got 6. Here also you can check, you got 6 ways. Here also you got 6 ways, and here also you can just check, it is 6. Okay, so so now you can just see this is 3p2, that is 6 number of ways. 6 number of ways. Clear? On the same way you have to go for properties. On the same way you can go for properties of NPR. The first property you can just see here, NPN. The first property you can just see here, NPN is equal to n factorial. NPN is equal to n factorial. Okay, NP0 is nothing but 1. NP0 is nothing but 1. NP1 is nothing but n. Okay, NPn minus 1 is nothing but n factorial. So please remember these properties, that is NPN is going to be n factorial, NP0 is going to be 1, NP1 is going to be n, NPn minus 1 is going to be n factorial. On the same way you can go for third and fourth property. On the same way you can go for third and fourth property, that is NPR is nothing but n into n minus 1 PR minus 1, r into n minus 1 PR minus 1 plus n minus 1 PR. So this all formulas you have to remember. You have to remember, then only you can solve some questions in CET. Okay, so here already these things are covered in offline classes, I also know, but when we go for CET we have to get revise all these things, and some of the things will be also new for you. That things also we have to concentrate. Okay, so don't worry about that. The definitions will be over, the properties also may be over, but property number 3 and property number 4, these things, most of these things will be not done in your offline classes. So go through property number 3 and property number 4, that is NPR is nothing but n into n minus 1 PR minus 1 equal to r into n minus 1 PR minus 1 plus n minus 1 PR. Okay, and fourth property you just see n minus 1 PR is going to be equal to n minus r multiplied with n minus 1 PR minus 1. So here property number 3 and property number 4 is very important. So please go through this third property as well as fourth property. Third property as well as fourth property. Okay, So now important results on permutation. These things will be never done in your offline classes. Have some patience. Okay. So if you have patience, you can understand CET classes and you can also understand some new concepts. These things are going to be never done in theory type of classes, and these things never going to be done in your offline classes. So please concentrate on that. That is some of the important what results on permutation. Some of the important results on permutation. Here, this is very easy, which is also known to you. No problem, you can understand this. That is the number of permutations of n things taken all at a time. P are one type, and that means one kind. Q are second kind. R are the third kind. So the remaining distinct, and the remaining are distinct. So that means n factorial divided by p factorial into q factorial into r factorial. Okay. So this is called your permutation, where you have n things. In that, p are one type, q are second type, and the remaining are distinct. Okay. And third kind also you have, that is r. Okay. So now you can write it as n factorial divided by p factorial into q factorial into r factorial. That means you just see here, you have n different things. You have n different things. In this n different things, you can just see some of them are same. Some of them are same. That means they are first kind. That means they are first kind. Okay. And there are some objects which are of second kind. Which are of second kind. Okay. And in that, some are other different kind. Okay, like this. Clear? So now the remaining things are distinct. The remaining things are distinct, like this. Okay. So you can just see here. These are the some of the objects what we have. These are the some of the objects what we have, in which you can go through it and you can understand. Okay. That is, see, these are of one type, and these are of the second type, and these are of the third type, and the remaining are distinct, and the remaining are distinct. Now if you get problem on this, if you get problem on this to calculate the permutations, means totally these are n number of objects. Totally these are n number of objects. In that, let us take this is r, let us take this is p, and let us take this is q. Okay. So that is r factorial, p factorial into q factorial. So which are of same kind and they are repeating. Which are of the same kind, they are repeating. We have to divide them. We have to divide them as r factorial into p factorial into q factorial. Okay. So that is n factorial divided by r factorial into p factorial into q factorial. Okay. So this is the ways of counting. This is the way of counting of permutations, in which you have total n objects. In that, p are of one kind, Q are of the second kind, R of the third kind, which are repeating, So on that you can just answer, that is n factorial divided by r factorial into p factorial into q factorial. Are you getting my point? Okay. So this is your first one. Okay. And you see the second one. The number of permutations of n different things taken are at a time when each thing may be repeated any number of times. That means that will be equal to n to the power of r. Okay. The number of permutations of n different things which are taken are at a time when each thing may be repeated any number of times. Okay. So that is called n to the power of r. Okay. And you can go for the third one, where you can just see number of permutations of n different things taken are at a time when particular thing is to be always included is called r into n minus 1 p r minus 1. R dot n minus 1 p r minus 1. You see the second one. Number of permutations n different things taken are at a time where particular things never taken in each arrangements is given by n minus 1 p r. Okay. You just go through C, D and E. You just read them and you can understand them, no problem. So quickly I will go for the next problems because I have shortage of time. Okay. So these are the some of the formulas which we are going to use in our problems. So please concentrate on them. And if I get more time in the next sessions, I will take the examples on this particular concepts and I will explain them. Don't worry about it. So quickly we can go for this problem. See this. How many number of 4 digits can be formed by using 1, 2, 3, 4, 5, 6, 7? At least one digit is repeated. Are you getting my point? So now you just see, you have to make 4-digit number. Okay, by taking 7 different numbers. Okay, you have 7 different numbers. Out of this 7, you have to choose and you have to make 4-digit number. Such that at least one digit is always repeated. Okay. So at least one digit is always repeated means what? Total number of ways minus no digits are repeated. Are you getting my point? Total number of ways minus no digits are repeated. So if I cancel no digits are repeated, what you are going to have? You are going to have at least one digit is repeated. This will be equal to what? At least one digit is repeated. So my dear students, if you remember complement set, if you remember the complement of a set, then this thing is very easy. So that's why you say here complement of a set. You remember complement of a set, that is u minus a is equal to a dash. Okay. That means now I need complement of no digits repeated. No digits repeated means what? You have one set A Now here I need this is the set of no digits repeated. This is the set of no digits repeated. In this set I have no digits repeated. Complement of this will be what? This particular thing, where we say at least one is going to be repeated. In this area you are going to have at least one thing is repeated. That means from your total number of possible cases, you have to subtract the total number of repeated cases. Okay, so then you are going, total number of not repeated cases. So you are going to have total number of repeated cases. Clear? So at least one digit is repeated means total number of the ways minus no digit is repeated. No digit is repeated. So I have given the formula. Everything I have written on the screen. Quickly calculate and tell me the answer. We can wind up this class. Quickly we can wind up this class if you give the answer. At least one digit is repeated. At least one digit is repeated is equal to total number of ways minus no digits are repeated. No digits are repeated. So you just see total number of the ways will be how much? You can just calculate total number of the ways. That is no digits are repeated means here you can take 7, here you can take 6, here you can take 5, here you can take 4. Okay, and the total number of the ways will be 7 to the power of 4. You can just see here n to the power of r. You just see this n to the power of r. Okay, r is total number of ways selected, n is total number of things, n different things are taken at a time. Okay, so n different things, that is 7 different numbers, 4 taken at a time. Okay, 7 to the power of 4. So 7 to the power of 4 minus 7 into 6 into 5 into 4. So you just calculate it and tell me what is 7 to the power of 4? 49 into 49. So you just calculate 49 into 49 and tell me the answer. So 49 into 49 will be 2401 minus, here you can see 7 into 6 into 5 into 4. 7 into 6 is 42. 42 multiplied with 20, that is 840. Okay, so 2401 minus 840. 2401 minus 840 will be equal to 1561. 1561. That is option C. That is option C. Okay. So therefore 1561 will be your correct answer. Clear? That is option C. This is one of the your JEE mains question. This is JEE mains question. Okay. So therefore you got 1561 number of ways. So some of you were telling that these things are already over. So now tell me, is this over in your regular classes, offline classes? No. Okay. So that's why I say have some patience. Some of the things will be over in offline classes. Some of the things has to be done in the online classes which are not done in your offline classes. That's why always have some patience. You are going to learn some new things. I think all of you have understood this problem. So quickly give me thumbs if you have understood this problem. Quickly give me thumbs, all of you, if you have understood this problem. so that I can go for the next concepts in the next class. Okay. Okay, so we can continue these things in the next class. Thank you everyone. Let us meet in the next session. Take care and bye.